Hello everyone. In this video, we are going to study about list comprehensions. Okay. So list comprehension provides a concise way to create list. Okay. So list comprehension is also about creating list. Okay. So we create a new list. But how do we create it? We create it in a very concise manner. That means very short and crisp manner, right? Which is very understandable, readable, and very short. So, common applications are to make new list, right? This is the main purpose of making new list, where each element is the result of some operations applied to each member of another sequence or iterable, right? So, what is there? That we are already having one sequence. Let us say 1, 2, 3, right? Now, on this 1, 2, 3, I want to perform on each element. I want to perform a common operation. Let us say square, right? So, I want to square each element and I want to make a new list of those squared elements. That means 1 square, so 1 comma 4 comma 9. This is what I want a new list should be created, right? So that is one purpose. So for that purpose, what we can use, we are having multiple ways and all those multiple ways are written here, right? All the samples are given, but then we will see that how list comprehension is the best choice because that is very concise. Okay. So that is one purpose of using it, and then also we can use it for creating a subsequence of those elements that satisfy a certain condition. So let us say again this 1 2 3 only is my sequence, right? Now from this sequence I want to capture a subsequence which maybe satisfies some particular property. Let us say my condition is that all the elements should be greater than equal to 2. In that case, from 1 to 3, only 2 and 3 should be extracted, right? So that means according to a certain condition, a new sequence should be generated, right? So for these purposes, we can use list comprehension concept, okay? So like for example, as I was giving the example of square, that same example has been taken here, and first of all a brute force method has been applied, that how can you do that, right? So one square list has been taken which is empty right now, and after that for x in range 10, so I took the example of 1 2 3, but here the range is till 10, right? So basically from 0 to 9 it is going to generate the numbers. And in that what to do, so whatever our squares list is there, in that list what I will append x square to, right? This is exponential operator. So x square will be appended. So first of all it is 0, so 0 square, then 1 square, then 2 square which is 4, 3 square 9, right? Like that it will go till 9 square which is 81. So like this the numbers are getting generated and they are getting stored in the squares list. So this is one way of doing it, right? Now the thing is that here you have to note one thing, that this creates or overrides a variable named x, right? So here what is happening, this whatever variable is there x, that is getting overwritten every time, okay? Because first of all it is 0, then 1, then 2, like this. So the x value is getting overwritten, okay? So named x that still exists after the loop completes. We can calculate the list of squares without any side effects using. So let us say any side effect we don't want, and in other way we want to create it, so other way is also present, that is this one, that is using lambda expression. About lambda expression I have discussed already in some previous lecture, you can go and watch it. So again, so whatever we are doing here, that is squaring the numbers from 0 to 9, that same thing we can do in this way also, right? So here squares is there, right? In this the list will be stored. So here by using this list function we are creating the list, right? Inside that again one map function is there which is mapping two parts, right? So the first part is this, which is your lambda expression, where lambda x, okay, and then x square is there. That means here what will happen, that x square will be generated, right? And they will be mapped where, they will be mapped to this sequence where 0 to 9 is getting generated, right? So first of all 0 square is there, so 0 square, that means 0, right? Then 1 square 1, then 4. So like this the numbers will be generated. Overall, it will be converted to a list by using this list function, and that will be stored in this squares. Okay, so you can try, you can just copy paste this particular statement in your editor, and you can see, you can run the code and you can see that you are getting the output or not, right? So this is another way of doing the same thing. But one other way is also there how we can do it, and this is this one, right? So here what is there, squares is equal to x square. So first of all, it is written inside square brackets. You have to notice each and everything, these are important here. So square bracket, because list we write inside square bracket only, right? Inside that, what is written inside that, x square is being done. So squares is equal to what, it is generally containing x square. For what? So for x in range 10, right? So that means whatever this, you know, right, that if this part you execute, then this means the numbers from 0 to 9 are getting generated, right? Now whatever that x is getting generated, like first of all 0, so 0 square actually is getting stored in squares, then 1 square, then 2 square, 3 square, in this way till 9 square, right? So this is what is known as list comprehension. Okay, so this particular is known as list comprehension, and this you can see as compared to the other previous two codes like this one and this one, this last one is the most concise and readable, right? Very clearly you can understand that x square for x in range, so anyone can directly see and understand that here x square we are performing for every x which is getting generated in this range, right? So this is what is list comprehension. So a list comprehension consists of brackets containing an expression. So as I said, brackets are important here. So first of all, brackets are there. After that, it will contain one expression like here x square. So this x square is the expression. Okay, so here what you will write? Here you will write exactly that expression which actually you want to calculate, right? After that, it will be followed by a for clause, like here one for word is written, right? Then 0 or more for or if clauses. So after this for, more fors and if you can write, which we will see other examples. Okay, means if you want to complicate it, some other like for is there, again nested for is there, nested ifs are there, that you can implement here. So how to do that, we will see the example, but as of now here nothing is there, that is why it is written 0 or more, right? All right, the result will be a new list resulting from evaluating the expression in the context of the for and if clauses which follow it, right? So what is happening, one new list is getting generated. How? By evaluating this particular expression, right? And it will be evaluated for what? It will be evaluated for all those values which are followed after for and if clauses, if it is there, right? Okay, follow it. So for example, this list, okay, so we will see this later. Let me show you one example from my side that how it is going to work, right? So this is the shell, you can just invoke the interpreter here, and after that, let us say, so their squares has been done, we can do cubes now. Let us say, okay, so cubes is equal to what? Cubes is equal to, here exactly the expression you have to write what you actually want to calculate, right? So I want to find the cube, so you can write here, let us say y, I'm using the variable y. Okay, so y cube I want to perform, so this is how you have to write, and this you want to perform for what? So for which numbers? So for y. Okay, in, now their range has been used for generating numbers, but here some iterable, as you saw the word here, it was written that here some kind of iterable should be there, here another sequence or iterable, right? So instead of range you can write anything on which we can iterate element by element. So let us say another list I'm taking, and in this we are storing some values, let us say some random values, okay, like this. So this is my list, and here for each element I want to calculate the cube and print it. Okay, so it has been done and it is stored in cubes. So after that, if I print cubes, then you see, first of all 2 cube has been calculated, which is 8, then 7 cube, which is 343, then 64, 27. So in this way it is working. So this is what is list comprehension. Okay, all right, so you can use this for other tasks also. Let us say, okay, let us say one random example is there, which is words. Okay, words. words is equal to, now in this what I want to perform, I want to perform something like x plus, and let us say here we can add high. Okay, so that means what is my operation, that whatever strings are there, to that string high should be added at last for every string. Okay, so I can write it this way. So this is my entire expression, and this I want to perform for what? So for x in, now here also some iterable you have to give, so some words we can write here, that is, let us say some names, right? So like this you can write some names. Okay, and then you have to put the brackets, and if you hit enter, and then if you print the words, then that is what is done, right? So Tom high and then John high, right? So like this you can use it for doing some common operation on each and every element of a sequence. So this is how you can use it. So you can try some more examples by yourself, and otherwise let us see the next point now. Here what was written, so here one more example has been given. So this list comp combines the elements of the two lists if they are not equal. So here you see how two list has been used. Okay, so here actually what is the expression? Expression is x comma y, that means tuples are getting created, right? By seeing the parenthesis you should understand tuples are getting created for what? For x, so whatever is the first element x, that has been taken from this list, which is 1 2 3, and for y, so for y the elements has been taken from this list, which is 3 1 4. And when the tuple will be created, so there is a condition, which is the if clause, right? Which is the if clause. So I hope it is visible here. The clause is if x is not equal to y. So if they are not equal, then they will be made tuple, and that is printed. So as you can see here, 1 comma 3, 1 comma 4, 2 comma 3, like this they have been used. Okay, but here 1 comma 1, this is not present. Why? Because x and y are equal, so that is why. Okay, now this is actually equivalent to this particular code. Actually, let us say if you don't know list comprehension, then how you can do it? You can actually run the loop. Two nested loops will be there. Inside that again if clause will be there, and then if the condition is satisfied, you can append it, right? But here you see so many lines of codes are required. Okay, and nested looping and all are done, but this part only is written in such a concise manner here, right? So that is what has been shown here. Now here you have to note how the order of the for and if statements is the same in both these snippets. So here also you see the order is same. First of all for x, then for y, and then if clause is there. The similar order is present here also. First of all for x, then for y, and then if clause is there. So that is going to be similar. Okay. Now if the expression is a tuple, example the x comma y, in the previous example it must be parenthesized, right? Which I told that if it has to be a tuple, then how the interpreter can understand that. So for that you have to provide the proper symbol, right? So then it will be done. After that, this entire section, multiple examples are given, multiple list has been taken. So okay, based on that, multiple operations has been done, list comprehension and all, and the list are generated. So I will recommend that you go through each and every example and see that how the numbers are getting generated, and also try it by yourself in the editor. Okay, all right. So now list comprehensions can contain complex expressions and nested functions also, right? So like here you see this is the entire expression, okay, which is containing again nested functions and all. First of all str function is there, inside that round function is there, right? So like this also you can write the expressions. So it can be in any form, it can be as complex as you want to make it. Okay, all right. After that, nested list comprehension is also there. So in this case, the initial expression in a list comprehension can be any arbitrary expression. As I said, you can make it as complex as you want, right? Any functions you can write, whatever operators you want to apply, as the requirement you can make it. Okay, so it can also have including another list comprehension. So that means here whatever expression we write, okay, in place of this expression itself, any other list comprehension can also be present. That is the meaning of that line. Okay, So for example, we can see here, like you can see the 3 cross 4 matrix has been taken here, right? Now the following list comprehension will transpose. Okay, so this matrix, let us say if I want to transpose, what is the meaning of transpose? The rows becomes the column and columns becomes the row. That is the basic meaning of transpose. Okay, so if you want to perform that, then in list comprehension, how can we do that? We can do it in this way. Okay, so as you can see, the main for in range 4, if this part you separate, right, then before this what is there? Before this we always write the expression. So that means this is my expression, and this expression itself is containing another list comprehension, right? So this is how it has been done. So what is the meaning here again? So inside this, if you see, this itself is one list comprehension, right? Where what is there? So row of I, this is the expression, right? Row of I, so you can take the rows from here for row in matrix, right? And again on those rows what is applied? For I in range 4. So like this, if you write, the list is getting transposed. Okay, so I will recommend that you, after the lecture, you just try to dry run the code and see that how the elements are extracted and how they are getting transposed. Okay, all right. Now, as we saw in the previous section, the inner list comprehension is evaluated in the context of the for that follows it. So this example is equivalent to, so that means here whatever inner expression is there, this is actually working for this particular for. Okay, and using that, one list is getting created. Now on that new list, again this whatever for clause is there, that is getting applied. Okay, so it is very similar to this particular code. You can write it this way also for I in range 4, right? Transposed dot append row of I, right? So in this manner also you can write the code, which in turn is the same as this one. So again that particular code you can write in this format also. This is little bit more lengthy as compared to that, right? So just for solving one question, multiple ways are there, and here all the ways are shown here. All right, so in the real world you should prefer built-in functions to complex flow statements. So like here, complex flow is there, right? First of all, for is there, again inside that you are doing something, then again for is there, inside this maybe some if clauses and all you might use in some kind of program and all. So for such kind of complex flow statements we should go for built-in functions. So one such function we can use, which is known as zip. Okay, so the zip function would do a great job for this use case. So how we can use zip for transposing? So that code has been written here, list of zip of the matrix, right? So here what will happen, actually unpacking and all will be done, which I have already taught in previous lectures, so you can go and check it out. But otherwise zip function can be used for transposing the matrix in this way. Okay, so I hope it is clear. This was all about list comprehension in Python. So I'm ending this lecture here. Thank you.